Hello folks, today we're on 10-5 Pythagorean Theorem on page 280 in the Green Book. Two objectives here are to use the Pythagorean Theorem to find a missing side of a right triangle, then to determine whether a given triangle is a right triangle. Okay, so as I said, right triangle. So right here to the left we have a right triangle. You know that because of the right triangle symbol right here. Okay, this is our leg, and hypotenuse. The hypotenuse of a right triangle is the longest side. Okay, the other two sides are legs. The legs make up, when they come together, the right triangle. You can see that right there. Okay, now we're talking about the Pythagorean theorem. The theorem is a squared plus b squared equals c squared. So let's put those variables actually on the triangle. So your hypotenuse will always be c squared. Okay. Your legs will be a squared and b squared. I always go with a squared is the shortest side. You don't have to do it. It doesn't really matter where you put it. It's just my rule to always kind of put it right here. And then b squared is going to be your second longest side, which is right there. Okay? So as I said, the Pythagorean theorem is a squared plus b squared equals c squared. Okay? Now, Homer might want to know over here, as he's thinking, okay, a squared plus b squared equals c squared. But what does that actually mean? So, well, Homer, in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. If a and b are the legs and c is the length of the hypotenuse, then a squared plus b squared equals c squared. Okay, so let's try this bad boy out. Oopsie. Okay, so we have a right triangle here. We know that because of our right triangle symbol right there. I can write it. Okay, again, we have our A side, B side, and our C side. So let's say that A is going to be 9, B is going to be 12. We don't know what our hypotenuse is, so that's when we bring in the Pythagorean theorem. So we know that our A is 9, or 9 squared. Oops, wrong color, sorry. 9 squared plus 12 squared. We don't know c squared, so c squared it is. Then we're going to square each number. So 9 squared is 81. 12 squared is 144. Bring that back down to c squared. Okay. Again, we're solving for what c equals. So 81 plus 144 is 225 equals c squared. Now, remember, what we've talked about is that squaring a number and square rooting a number are inverse of each other. Okay? So if I want to get rid of this 2, or this squared right there, I need to square root it. So I'm going to square root that. It's going to break that out of there. It's going to equal c. Whatever I do on the right side of my equation, I have to do on the left, or vice versa. So I'm going to square root 225. The square root of 225 is going to be 15. Okay? So c equals 15. All right, so it's basically substituting or evaluating expressions, but actually we're solving for a right triangle using the Pythagorean theorem. Okay, so it's all skills that we've used before. There's just a new term for it, and we're actually solving for something using the Pythagorean theorem. Okay, all right. So sometimes they won't give you an actual drawing of a triangle. They'll just give you 3 different lengths of a triangle. So they'll say like 10 meters, 24 meters, 26 meters. Okay, so obviously these are 3 different lengths of a triangle. I hope, or I'm assuming some of you are wondering, how do you know which one's A, B, or C? Well, remember, C, your hypotenuse, is your longest length. The longest length here would be 26. So this would be your C, or your hypotenuse. Again, A and B can be flipped around, but I always go with, just for myself, A is the smallest. We're going to go with A here and B here. Okay, then we're going to put it into the Pythagorean theorem. So we have 10 squared plus 24 squared equals 26 squared. Okay, so I want you to pause the video, square all these numbers, and see if they're going to equal each other. Okay, hit play whenever you're ready to see if you got it correct. Okay, so when I simplify this down, I got 10 squared is 100, 24 squared is 576, and 26 squared is 676. So we're going to break this down just like any other equation. I'm going to add these two numbers together. When I did that, I got 676, which equals 676. So this is a right triangle. Okay, when you add a and b together, a squared plus b squared, it has to equal c squared for it to be a true right triangle. So that will be true. Okay? Alrighty. Okay, the last thing we're going to talk about here is problem solving using the Pythagorean Theorem. You're going to have a lot of questions involving ladders or tilting things against a solid straight wall, or a pole that's leaning against a building, or a ladder leaning against a building. So I want you right now to picture this for me, okay? We have a building that's 15 meters tall. So a building 15 meters tall. Okay? I have stacked a ladder against it so that the very top of the building, right here, I'll draw it for you. Okay, right? This is your building. It's 15 meters tall. Okay? Stacking, or putting a ladder up against it right here in orange. That's my ladder. I know it looks nothing like a ladder, but let's just pretend it's a ladder, okay? The base from the bottom of the building to the edge of the ladder right here, let's say that is, right here it's 7 meters from the wall. 7 meters from the wall, okay? So right here, if you look close enough, this has created a right triangle. Right here, okay? I want to know how long the ladder is, right here in the orange, okay, which is your C, okay, or your hypotenuse. Right here it's 15 meters. So this is my A, this is my B, we don't know our C, so let's plug this information into the Pythagorean Theorem. So that's 7 squared plus 15 squared equals C squared. Oops. Okay, 7 squared is 49. 15 squared we know is 225. We have our C squared here. Okay, this is going to be 274 equals C squared. Again, I'm going to take my square root on each side to get down to just my C. That's what I want. This equals C. Now, 274 is not a perfect square, so this is where you'll need to use your calculator for right now. Or if you learn that fancy trick yet, then I would use that fancy trick on how to find the square roots of non-perfect squares. Your answer is going to be around 16.57, approximately. So I'm just going to round to 16.6. So C is approximately 16.6 meters. Whoa, it's not an M. It's a squiggly line. Okay? Again, people use this in everyday life all of the time, whether it's on a building, whether it's in a project, whether it's an architect, a pilot. That's not what I'm saying. But anybody that builds things or that has to model things, they're going to use the Pythagorean Theorem. Okay, the last definition that I want you to have in your notebook is the Pythagorean Triple, which is a group of 3 numbers that can form the side lengths of a right triangle. So whenever you do a problem, whether it's a word problem or just any other question in the try these or in your workbook, if the 3 side lengths, when they are used in the Pythagorean Theorem, equal each other, they're called the Pythagorean Triple. So for instance, all the ones that we've done that either we solved for a B, or C, or that we had all 3 numbers and they equaled each other, those are called the Pythagorean Triple. So let's do this one together. Let's do 14, 15, and 16. Okay, so right now I want you to pause the video and try to tell me if these 3 side lengths would equal a right triangle, and then hit play and check your answer. So you probably discovered that 421 does not equal 256, so these 3 side lengths could never make up a right triangle. Okay, so there's no Pythagorean Triple here. Let's do, in your notebooks, 2 through 6, and then try these. Try these. numbers 2 through 6. Show all of your work. Take your time and think about the vocabulary that you learned in 10.5. Okay? All right, I'll see you in class. Adios, amigos.